Hey everybody, welcome to online learning. I wish we could be in person, but we're gonna try to make the best of our situation. So today is the lesson for Wednesday, November 18th. And what I'm looking at is right here, this advanced Pythagorean theorem problems. So I'm gonna go through these notes really quickly, and then your assignment today is to go through it says assignment. You have 3 triangles to complete and 2 word problems. So you can find this on the Google Classroom. Here's geometry, here's your class, and then I'm gonna post for you when we can have Zoom. So today, Zoom, Wednesday 11/18, here's the Zoom meeting link. And then right above it's the assignment, Advanced Pythagorean Theorem. You could also go to classwork and click on this assignment. And I actually want you, here's all of you guys, I want you to turn it in here so I have all of your stuff in one place. That would be wonderful. So if you could just take a picture of your assignment and upload it onto this website, onto the classroom. All right, so we're gonna start by foiling. And just a reminder, so I'm looking up here, it says foil. And in case you don't remember, foil means, I'm going to try to put this down so you can see. Foil stands for front, outer, inner, and last. And this is for when we have quantities that look like this, x plus 3 squared. So to square something means to multiply it by itself twice. So we have x plus 3 times x plus 3. And we're just going to multiply the front 2 terms, x times x. The outer terms, x and 3. The inner terms, 3 and x. And the last term, 3 times 3. So that gives us 9. And we can combine here, we've got like terms in 3x and 3x. So we have our final answer, x squared plus 6x plus 9. Let's do one more just to make sure. The next one is x minus 9 squared. That means we're going to multiply x minus 9 by itself twice. So we have x squared minus 9x minus 9x again, and last plus 81. Notice this back term is always going to be positive because you have a negative times a negative. That makes positive, or even if you have a positive and positive, that makes positive. The only ones that might be negative would be this middle term here. So in this case, we've got x squared minus 18x plus 81.
Plus 81.
Okay, so next up, I want to do this with Pythagorean theorem. So here's this picture. They want us to find the side lengths. And they have this is x plus 1, that's the hypotenuse. 3 is one leg and x is another leg. You'll notice too that all the triangles look the same, but obviously the side lengths are different. So the Pythagorean theorem is our a squared plus b squared equals c squared. A and b are our legs. So in this case we have 3 as a leg and x as a leg. So 3 squared plus x squared. And our hypotenuse c, in this case, is x plus 1. X plus 1 needs to be squared. Be very careful because this entire quantity x plus 1 needs to be squared, not just 1 or not just x. And be very careful that you don't just write x squared plus 1 squared, because as we've seen before, you have to FOIL to get the correct answer. So let's go through this. 3 squared is 9, and x squared is x squared. And here we're going to FOIL x plus 1 times x plus 1. This equals, so I get front x squared, outer x times 1, x times 1 again for the inner, that's just 1x, and then last 1 times 1 is 1. All right, let's clean this up. 9 plus x squared equals x squared plus x, and x make 2x plus 1. Now this looks like a crazy problem, but here's the great thing, is do you notice how I have x squared on one side and I have x squared on the other? If I try to move one over, let's say I try to move this x squared over and I subtract x squared on both sides. Well, it cancels out on the left side, that's what we wanted, but it also cancels out on the right side. So this equation became 9 equals 2x plus 1, which now looks a lot simpler to solve. So I'm going to subtract 1 on both sides. I get 8 equals 2x, and then divide by 2. So x is 4. That helps me find the side lengths because now I can plug it back in. This side is 4, and this side is 4 plus 1, 5. That's how we're going to apply this to the Pythagorean theorem.